Okay, so we're picking up on 6.1, and we're going to start with example 2. There. Let's see if I can make this a little less yellow. There we go. All right, so it says example 2. We're going to graph f of x equals x squared, g of x equals 2x squared, and h of x equals negative 1/2 x squared, and compare their graphs. All right, so on this one, I went ahead and filled out the table so we can look at those, and then we can graph our points for those. All right, so just to make sure we're understanding this, how to use the table, it's the same one we used in Algebra 1, and you should have used in geometry. But if we put x in, right, then this would be 0 squared equals 0. So the ordered pair I'm going to graph is 0, 0 for this one. Because I put 0 in for my x value in this equation. So then here I'm going to put 1 in. So that would be 1 squared is equal to 1. So I would graph, my x is 1, my f of x is 1. So I'm going to go 1, 1. Then if I put negative 1, or let's jump down here to 2. We could do 2 squared, because again, my x is 2. I'm putting that into this equation. So 2 squared equals 4. So I'm going to graph 2, 4. So over 2 and up 1, 2, 3, 4. So I don't want to show all these, but I'm going to graph negative 1, 1. So negative 1, 1, and negative 2, positive 4. Then I'm going to connect these in my parabola, and I'm going to label this one my f of x. And then I'm going to change my color. So now, okay, because I just put all these on the same one so we could see, I'm plugging 0, the same values in to see how my graph has moved into the 2x squared. So I'm going to have 2 times 0 squared. Well, that's still 0. So I've got a graph at 0, 0. Let's see if I do a different one. Or we could do the 1. So we've got 2 times 1 squared. Well, 1 squared is 1. 1 times 2 is 2. So now I'm graphing 1, 2. So 1, and then I'm going to go up to 2 this time to graph. So if I put a 2 in my equation, it's going to be 2 times 2 squared. So 2 squared is 4. 4 times 2 is 8. So I'm going to graph 2, 8. Yeah. Okay, so 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Are there questions about how we're putting these numbers in? Okay, why is because in order to graph this, we have to have some x values. I did not. I actually picked ones that were going to be mirror images. So 0 for f of x is x squared is our parent function. 0 is always the vertex of it. And so then I picked 1 and negative 1, so I would have the mirror image. And 2 and negative 2, so I had the mirror image. Those are going to be like the 5 standard ones to pick unless you have a fraction. Like if you had f of x equals 1/2 x squared, in that case I would pick numbers that wouldn't give me fractions. So I would pick 0, 2, and negative 2, right? Because if I multiplied 2 by 1/2, I would get a whole number. But then I would pick 4 and negative 4 as well, probably, instead of like picking the 1, because that would have given me a fraction for my answer. So these aren't random, but like those are just your standard. Just pick 0, negative 1, 1, 2, negative 2. Unless otherwise you want to do something different. But you could pick any number you want. But you have to have a graph big enough to help you graph it. So don't pick like 100. Ethan. No, because we do the power first, right? So we have to do the square, and then we multiply. Good question. Yeah. So then if we go ahead and graph, so we have our axis of symmetry. We're going to graph our other points, negative 1 and 2. So -1 and 2. Oh, wait, hold on. Yep, -1 and 2 is that one. And -2 and 8. So -2 and 8. 1, 2. Okay, there we go. It's a little thinner. Okay, so this is my g of x graph. So it says compare the graphs including their minimum or maximum. So we could start there even and compare the g of x. What can you say about the g of x to the f of x? G of x, okay, is skinnier than f of x. What'd you say? They have the same minimum. Okay. G of x and f of x have the same minimum. So I'm just going to put min, period. Okay. Perfect. So now let's do the h of x. So this is what I was talking about, Brandon. I wouldn't necessarily like to pick 1 because if I put 1 in here, I'm going to have -1/2 times 1 squared. Well, 1 squared is 1. 1/2, or -1/2 times 1 is 1/2. So I'm graphing 1 and -1/2. So 1.
Wouldn't it be -1/2 and not 1/2?
Well, it's a positive 1, and yeah, -1/2.
Yeah.
That's what it says. It is a -1/2.
I thought you said positive the first time and I got confused.
Oh, I'm sorry. I might have said positive. I do make those mistakes. So I could have. But it does say -1/2. So I'm going to go over to 1 and go -1/2 there to put that point. And so like with the 2, so it's -1/2 times 2 squared. Well, 2 squared is 4. So now I've got -1/2 times 4, which is -2. Uh-huh.
So you're saying we can pick whatever numbers we want, right?
Yeah.
To plug it in. So if we put in 0, it's always the vertex or whatever, the minimum or whatever, is always going to be on 0, 0.
Uh-huh.
But there's graphs where they're not. So how would...
There are graphs where they're not. This one, it is there, but that's what we're learning about.
Plugged in, so let's say there's an equation for that other one, like the g of x or the f of x or whatever, like there's an equation like one of those for one that's not on it. You plugged in 0, wouldn't it still come out as 0, 0?
Nope, it wouldn't.
It wouldn't?
Uh-uh.
Okay.
Nope, it's going to come out as like 0, 3 or 0, -7 or whatever.
Okay.
So yeah, because it can move. And that's the thing, is we're getting to that point of being able to look at the quadratic and manipulate it to see. But the parent function, f of x equals x squared, is the parent quadratic function. So when we're trying to compare them to the parent currently, and a lot of times that's what it is. They're like, compare it to its parent function. That is always x squared. That's it. Because all these other numbers, and that's what we're trying to see, is how these other numbers affect the parent function. So when we had a positive 2, like this is our a value, so when we had that positive 2, it made our quadratic, our parabola, skinnier. Didn't move it, right? Just made it skinnier. So now we're looking, well, what happens when our quadratic is a negative a? Okay, so in this case, if we're graphing it, we have 0, 0 if we go ahead and graph it, and then 1, -1/2, -1, -1/2, 2, -2, so 2, -2, and -2. Yeah, I was like, either way, because it's, right, it has that. So if we're comparing this one, g of x to f of x, or h of x, pardon me, what can we compare with h of x?
It's like opposite of f of x, basically.
Okay, so what's it done? How can we describe opposite better?
Maximum instead of minimums.
Okay, so h of x, okay, has max instead of min. So we might have said that it flipped across the x-axis, right? Or it's a, anything else about it? It's like the thickest or like the widest? Okay, so it's wider. It got wider than its other one, didn't it?
Little chunky boy.
Okay. So the h of x is wider than the f of x now. So looking at that and seeing, okay, we can make some conclusions about those values. Like we see that that value changes things. Did it move our parabola left or right? No. Does it move our parabola up or down? No. The number in front of the x makes it skinnier, or it tells us, or skinnier or wider, and it tells us if it opens up or opens down. Okay, so let's go to your next page because that's where we're gonna look at some more. We're gonna get confused even more. No. We won't have, it won't be a parabola that goes sideways. There are shapes that do go, it's a hyperbola, or
No, it's like the shape.
right, but it goes sideways. Yeah.
But it's not a parabola, but you can get something that looks like that. Right?
Yes, just not currently. Yes, Lauren.
So for number 7, do I just add all these up?
To find the area, no, you have to separate it into 3 different shapes and find the area of each one. It's the area addition postulate. So we're talking geometry there, sorry. Okay. But like, so I want you to graph it, but seriously, like, are there questions about how the table works? Because if it's easier for you, you could set up an you could set up separate tables and have x, and then have your f of x here. And then you could do x and your g of x. Because a lot of times, then we would have, you know, like our x / f of x coordinate here is what we would have done in the past. Like if we had, say it was -1, then we would say our work here would be the 1/2 times -1 squared. So -1 squared is 1, so this is 1/2, and -1, so this would be -1 1/2 that I would graph. My pencil's not working. So you can do it separately or whatever. I just like condensed all the work for you because I want you to practice graphing the parabola. So I'm going to pause this and I want you to graph your 3 parabolas. Okay? And example 3. Okay, so great conversation pieces there. So we notice that they're all the same width. Just moved up or down. Or I'm going to put up / down. Fantastic. So if we look at the equations of all of those, what is different? The b variable, okay, or the adding or subtracting something, because they all have the 1/2 x squared. Every single one has that in common. All right. The one that doesn't have anything added to it, if we look at it that way, kind of, is that first one. So its origin stayed at 0, 0. But if we look at the g of x, it has a +3 to it. I don't really know what. Right? And so where did it move? Up 3 on the x-axis, yes. I was like, I don't know what. There was a glitch in the system somewhere. In the matrix. Yeah. Okay. So we added 3 and it moved it up 3. Well, that's pretty cool. How about the other one? It has a -4. What happened to it? It moved it down 4. Yes. Okay. So that one moved it down 4. So that's what we can talk about. Okay. Is our g of x, okay, had +3, which moved the parabola up 3, whereas the h of x had a -4, which, right, it's going crazy on me, moved it down 4. Okay, So pretty awesome stuff there. But again, we're just trying to see those connections, like how the numbers move the parabola and shift it, because it's not quite like a linear equation. Okay, it's slightly different than that. Okay, so let's look at example 4. We're just going to, says, given the g of x equals, state the parabola's vertex, whether it's a min or a max, its domain, its range, and is the graph steeper or flatter than, I don't know how to get rid of this.
So how am I supposed to do 21? Because it says the floor of your classroom in both square feet and square yards.
It was, but I don't know what it was that my thing got.
Just start hitting buttons. You'll find it.
You're good. We did it in class. I measured it out. It was like 15. Technical difficulties are so much fun. All right, so let's look at this one. Given this equation, we're going to state all these things about the parabola. So, what are you thinking? Do we have to graph it?
I'm sure you don't have to, but I don't.
Okay, fair enough. If we can graph it. We don't know how not to do it without a graph.
Wait. Can you could just do the table. And
We
that
could
was
do
the points.
We could do the table. Okay, I'm going to pass out some graph paper in case we want it.
Because the -3x squared means that it's going to go like face down.
Oh, so you see some things.
So then it's going to be a max. It's going to be a max.
Okay.
Plus 4 means that the vertex is going to be.
The y-intercept is going to be like 4 higher.
Yeah, so it's going to be positive 4. So you can do it. You just have to look.
Okay, so I heard the -3 tells us that it's going to be face down, or we're going to say that it opens down because of the -3x squared. All right, and then you said the plus 4,
It's going to open.
so it's going to move.
And the vertex is going to be 0, -4.
Okay, so he thinks our vertex is going to be 0, 4.
So yeah,
You're good. Okay, some things that we could tell there.
that's all. That's
Oh,
The domain is always all real.
the domain is always all real numbers. Okay.
then your range. All you have to do is look at the floor. So it's going to be anything less than 4. It's going down.
So it's going to be that.
Such that negative or less than or equal to 4.
There you go. I was like, you said it and then repeating it. Good. And so because it's opening down, is the vertex a min or a max? It's a max. Sorry, I didn't get that down there. Good. And you said the vertex was 0, 4. Glorious. So how about, is the graph steeper or flatter than the graph of the f of x equals x squared?
It's going to be fast.
Because there's a positive number last time, right? It made it steeper.
Good question.
I'm writing the stuff down. We went through that really fast, and I got lost.
Okay.
So can you repeat it just a little slower?
Yeah. I was trying to keep up with them, so you're good. All right, so they said because this is a -3, the negative makes it open down. All right.
With a positive number, it's going to be u. But
Right.
if it's a negative number, it's going to be an n.
Okay, so it's going to open down, so we could draw it like this even. Then, from what we just looked at, we said since it had a plus 4 at the end, it was going to move it up 4. So our,
It's going to be 0, 0.
right, so our origin is going to be down here, and it's going to open up, but we moved it up. Okay, with it opening up, or so as it opens down, this is going to be a max. Our vertex here is the max of it. And so the vertex is at 0, 4, because it didn't shift it left or right yet. We don't know anything about that. So the vertex is still 0, and then because it shifted it up 4, this is 0, 4, which is our vertex. And then, so you good so far? Domain you said was all real numbers. The range then, since this is the max, is going to be all the numbers less than 4. So y such that y is less than or equal to 4. All right, so what do we decide about the graph? Is it steeper or flatter? You think it's steeper?
There's a positive number. I thought I got steeper. Not positive, I'm sorry. There's a whole number that gets steeper with like a fraction.
Okay, so it does. It's steeper than f of x. And it's more that the absolute value is greater than 1 is when it's steeper. So it actually doesn't matter if it would be a -3 or a +3. It's that absolute value of it. So yes, is greater than 1. What was that?
So if it's a fraction, can you explain that?
Yeah, so like here, your a value is -3. Right, so the absolute value of that is 3. Yeah. Okay, so then 3 is greater than 1, so we're going to have a steeper graph.
So
Earlier when we had the...
always be steeper, and if it's a fraction, it'll always be like flatter.
Right, if it's a whole, if it's a whole number-ish. Because earlier we had the -1/2 x. So the absolute value of that is 1/2. 1/2 is less than 1. So it is a flatter graph.
So you're looking at the number beside x squared.
Yep. So the negative or the positive tells you if it opens up or down. And then the value, so the 3, if you have a 3, a 7, a 12, it's going to be steeper. If you have a 1/2, a 1/3, a 1/5, it's going to be flatter. Any whole number is going to make it steeper. You got it. Okay.
If you have like 3 and 1/2, it's still going to be steeper.
3 and 1/2 is still going to be steeper.
If
You got
minus,
it.
like, yeah.
Because it's greater than 1. Good. All right. Then on the back, you have... No, this is just a summary charts of the effects that you all just discovered for yourselves. Okay? So we have the effects of A, right? If a is greater than 0, it opens up. So if you want to put, if it's a positive number, right? Greater than 0, this is a positive number. If it's less than 0 or a negative number, it's going to open down. If, again, it's steeper if the absolute value is greater than 1, or if it's less than 1, it's going to be flatter. And then we have the effects of C, that constant. So either if it's greater than 1, we're going to translate it up. If it's less than, 0, if it's greater than 0, we translate it up. If it's less than 0, we translate it down. If it's 0, you don't touch it. Yeah, it's going to stay right where it is.